Hello, everyone, and welcome back to the SOC podcast. I'm Ahmed, the CEO and co-founder of Qevlar AI, and my guest today is Raffael Marty, a cybersecurity leader and one of the early pioneers in SIEM and security analytics. Raffael has more than 25 years of experience in the field, including early roles at ArcSight, at Splunk. So please join me in welcoming Raffael. Raffael, how are you?
I'm great. Thanks for having me on, Ahmed.
Pleasure. Happy to have you with us. So today we will talk about a simple yet somehow uncomfortable reality, which is that for more than 20 years, security platforms have promised to bring visibility, to connect the dots. Yet when a real intrusion happens, analysts are most often left to manually piece together the attack timeline, to try to understand what happened after the fact. And most of the time they would discover signals that they hadn't seen before, that were not necessarily captured before. And so we'll try to zoom in about why this correlation solutions so far haven't been able to solve this, and what that actually means for SOCs, for defensive teams across the globe. Ready to dive into this, Rafi?
Let's do it, yeah.
All right, so let's start with the first... Yeah, please go ahead.
Go ahead.
So let's start maybe with the first question then. You have expertise with that. So SIEMs have been initially designed to be a correlation layer. Like that's core to their value proposition. That being said, even today, most postmortems that we see still include a moment where someone reconstruct the attack chain by themselves. They rebuild the timeline. They realize maybe that the alerts that they had didn't tell them the full story. So from your perspective, what went missing? What is the failure? Is it more of a query problem? Is it more of a data issue? Is it more of a reasoning engine problem? Curious to have your perspective on this.
Look, I think historically, like when the SIEM space started 25 years ago, we built very event-driven systems where initially we actually built the SIEMs because we had intrusion detection alerts and there were a lot of false positives and we didn't really know how to figure out which ones are true positives. And we started taking vulnerability data from the end hosts and starting to mash that up. That was the first piece of correlation that we actually did. It was not even just between events, but it was between events and sort of host states. That went really well, but very quickly that actually kind of disappeared. This whole state machine and sort of asset inventory and the SIEMs has gone away pretty quickly, and everybody started just correlating events with each other. And we kept sort of this view of this time series focused analysis, right? Now, fast forward to today, we're thinking differently. People are starting to talk about a context graph. Well, we thought about that before in the early 2000s, where we had an asset model. And we tried to build a user model and so on. But we didn't have the right tooling yet to really make that work. And with the advent of LLMs and these new approaches and faster databases and cloud compute and all that kind of stuff, now we're actually able to move sort of beyond event correlation to this whole reasoning layer, right? And that's really where we can start assigning meaning to events. And it's not a one-to-one mapping, but it depends on the context of things. But we can do that now, right? And so that's where we're really moving into managing incidents, doing root cause analysis, being able to help with cleanup. And so afterwards, rather than just having some event correlation and then having to do all this manual work, right? This is really where the agentic world has given us a huge leap to be able to basically imitate what an analyst would do, as you mentioned, right? Like you see an alert, well, it can go out and bring you all that context already, enrich things so that the manual work doesn't have to be done by an analyst anymore.
Yeah, I like what you're saying. And by the way, this is something that we do see as well with many of our customers today, which is that up until now, the correlation layer was based on the events themselves. And you just have too many of them. It's the signal to noise ratio is actually not good at all when you look at events by themselves, which is precisely what we're trying to solve. Like we're trying to build a layer that actually reasons on top of alerts and kind of bring them all together. And that was actually going to be my next question for you. Like today, when we say that a security team needs to see alerts as part of a wider campaign or as part of a wider attack chain, what does that actually look like from an operational standpoint? Like if you look at the day-to-day behavior of analysts, how are they expected to think campaigns, knowing that us humans are not the best at dealing with pattern recognition? I mean, if you see an alert in Jan, you probably forget about it a few weeks later. So how are we supposed, us humans, without the support of AI maybe, how are we supposed to deal with that issue?
First of all, I want to hone in a little bit on something you said. with regards to like some of the systems that I'm seeing being built out there. Right? As an advisor to many PE firms out there, I've been looking at a lot of these AI stock companies and new SIEM companies. Okay. One of the things I'm seeing is that a number of these companies are trying to patch the problem by basically building a layer on top of the existing SIEMs or whatever you want to call them, right? Like security analytics products. And that's a fundamental problem because you're dealing with a biased signal, with a signal you don't control. An alert that's being set up somewhere, you don't know how that's being configured, and you have no idea what you're not seeing, right? And so you're trying to fix something that is already inherently bad. And so we need to make sure we understand first the signals that are generated as alerts, and then also be able to go back to some of the raw intelligence and telemetry that's flowing around otherwise, right? So then from there, you're rightfully so saying that, well, how do we move into sort of maybe a adversary or campaign-based view of things, right? And I think that shift is interesting if you can make it and if you can really associate alerts with different campaigns or adversaries. And that's not always easy, right? How do you know necessarily? Sure, maybe certain TTPs are hinting that way, maybe certain other signs, certain properties of the attack, like the sources or something like that can show that. If you can, it's interesting because then you can try to figure out what is the objective of these guys, and from there you can abstract like, oh well, if they're a hacktivist group, well, they might want to mess with my data integrity. Maybe they want to steal data and publicly show it out there, or maybe mess with my availability of certain systems. So you can start figuring out what are these guys known for, where do I have to go hunting further, so you get sort of a leg up in the whole investigation flow, I guess.
And by the way, if we zoom in a little bit, if we drill down a bit more, do you think that this, I'll call it campaign thinking, do you think that this is something that can be systematized? Like, do you envision a future where maybe AI, maybe some sort of technology can do this? Or do you believe that this is something that is fundamentally only possible for the most experienced people on a given team?
I got to be honest, it's just kind of the first time I start thinking about, like, well, would we look at a sort of campaign-focused analytics, right? I think that what I'm seeing mostly today, what is being done is you test out certain hypotheses overall. Is these kinds of behaviors, do we see them, right? Like we know that from Intel sources, you know what the different types of TTPs are in a broad scope, right? Like, oh, these different adversaries are going about it this way, they're looking for these kinds of things. So you formulate hypotheses that then help you investigate whether that actually happened, and you start the whole hunting process that way, right? And so one of the things I'm seeing now, some companies come out and they actually have almost these automatic hunting agents that formulate hypotheses. They can learn from what they see and being discussed out there in forums and so on and so on. I think that's the closest that I've seen in terms of like, well, sort of a campaign-oriented approach. And I think that's probably, if I had to build a taxonomy on the fly here, right? It's like event to IOC to TTP to campaign to adversary, right? Like every different stage has a different way to express what they're doing. So I think campaigns you can probably encapsulate as multiple TTPs in a way to then search for. So that I think that kind of makes sense.
Okay, something maybe related to it. I'm thinking out loud here, but from related to this TTP idea, we see a lot of organizations that have actually access to threat intelligence feeds, but are not necessarily acting on it really when they are on the investigation side. A concrete example is we see a lot of cases where you have an alert that fires at, 2 a.m. The SOC analyst that is doing the shift have to act decisively, they have to act fast, so they don't necessarily have the time to gather all the context, they don't have the time to gather the tribal knowledge, the institutional knowledge they have about the organization itself, they don't have the time to collect all the IOCs, all the threat intelligence knowledge that they have, because they just need to rush the investigation. So from your perspective, what is the best approach to this? What's the mechanism that determines whether past context gets applied or not? And how can we actually fast track the SOC adoption of that specific mechanism?
So I think, first of all, I think threat intelligence is not just IOCs. However, where it is IOCs, the system needs to be able to automatically enrich your data and basically find the IOCs within your data already, right? Once threat intelligence becomes TTPs, very similar, right? The system should just be able to find these TTPs in your systems. But then I think the next level is really starting to capture an additional layer of intelligence or knowledge from the analysts, right? And that's, I think, where it's getting interesting. And that's, I think, where we are at today, starting to leverage the knowledge from analysts. It's funny, like historically, when I was at ArcSight already, I was like, gosh, I wish we could capture the analyst interactions and their decisions that they make on a per event basis, right? It's not that hard. It's like, oh, they take the event, they make it a false positive. Why can't we use that for reinforcement learning? And that has been sorted out, but not really. But now it's going way further. Now it's not just a specific event or a specific rule or alert that's being handled in a way, but it's a whole investigation. Well, can we learn from that from an analyst and start encoding that as knowledge in the system that is built up over time, collaborated on, and then becomes this new sort of context layer, and that being applied then overall again to make investigations much richer in certain pieces, additional intelligence beyond just having rules in the system that are very static, right?
Yeah, and I mean, you probably saw me smiling because I heavily agree with you, first of all. And beyond that, one of the features that our customers like the most is the ability of Qevlar to generate its own context. Once it investigates enough alerts, it actually builds what we call the historical context. So it learns patterns, it sees stuff. Beyond learning from the institutional context of the customer, it can generate its own. So sometimes, funnily enough, the AI can actually help analysts themselves uncover a piece of context they wouldn't have seen, or it would have taken them much longer. So I do agree with you 100%, but there is also more and more so when we're seeing it in our product and the way it's being used, there is this capability of the AI to itself create its own context, to itself suggest some context pieces, some memories to the analyst. And that's where the feedback loop gets even more interesting. The AI learns from the analyst, but also provides some insight, some visibility that they wouldn't have seen otherwise.
And I think that's the intelligence that can come on top of sort of the LLM-based intelligence, right? That you can start gathering. But it's only as good as your context is as well, right? If he doesn't understand the context, it starts abstracting things like, this is really, really important, while that might be important when you're looking at a financial system, but if it's a dev server somewhere, oh, that's very different. You have different sort of security profiles on both of them, right?
Yeah, absolutely. And maybe related to that, by the way, LLMs are a good approximation to the solution, but they cannot do it by themselves. Typically, you've mentioned the graph before. Funnily enough, at Qevlar, the core is actually a graph. So the LLMs would just help fill parts of the graph, but all the context lies in the graph. And the reason I'm saying that is, I mean, if you work with relatively small organizations with relatively small amount of context, you can still make it work with an LLM. If your customers are, the way we do, like German car manufacturers or global banks, etc., like these folks have a lot of context, and the window size of an LLM would simply blow up, and you would fall back on the hallucination issues, inconsistencies, etc. So from a technological perspective, LLMs are really good at semantic analysis. That's where we see them performing the most. They can help you extract context, but they will not necessarily recall it by themselves. So we have to kind of babysit them a little bit. And graph structures are very, very efficient at that. They were designed from the ground up to do that specific role.
No, and I think those are some important points, right? I think graphs are the right structure to capture knowledge about entities and properties around that. I think the other thing you mentioned is the LLMs are only as good as you use them, right? Like they have limits, they should have more larger and larger context windows. Yeah. But what people don't understand is like it's not just you throw a prompt at an LLM and you throw it some data. You have to do some engineering as well. You have to understand how they work. You have to understand what data you actually feed them and how, right? Like, are you using a RAG? Are you using a vector store? Are you using flat files with just information that you're attaching to it that fills up the context, and so on. So there's an engineering problem there that people are still a little bit ignoring because you can just do so much without being very smart about it, right?
Yeah, and that's an intriguing part of the LLMs, which is that they will always come back to you with an answer anyway. So they look very convincing. Right. Once you try them at scale, then you notice the issues that they bring. Maybe coming back to the campaign discussions we had before. Campaigns are clearly attacks are getting more and more complex. Like campaigns now, they span environments ranging from endpoint to network to email, etc. attacks are not as easy as they used to be. They're much more complex, maybe because of AI itself. It helps morph them into something that's much harder to notice, much harder to detect at first. And so somehow the attackers now operate across all these boundaries, while the defenders don't. They work in silos. You have teams focusing on security operations, teams focusing on vulnerability side, etc. So again, from your perspective, what's the technical reason for this cross-environment campaign visibility to be that rare? Why is it that hard for us, with the tooling we have right now, to be able to correlate that across your EDR and your, email gateway, for example?
What I'm seeing is not necessarily that there is a challenge with cross-correlating between these different data sources, right? Like a well set up SIEM at a Fortune 2000 company gets all the major data feeds from network to endpoint to email to cloud, right? Whatever it needs to do. I think for some reason we have drifted away in the modern SIEM architectures to single source correlations, which I just don't understand. Where I don't care whether I see something on the email, the endpoint, the network, it's a signal that I need to correlate with other signals. And so that's where it starts, being able to get the data, correlate across everything. But then you are hitting a problem with people. And sometimes this is probably where you're going with the question also, is it's an organizational challenge, and it's a knowledge challenge. Like the organizational piece, like you have IT running certain pieces of the environment and understanding the part of the environment. Email often is run by IT, right? Whereas the firewalls, the IDS, maybe even the SWIG is run by security. And now, well, where's the knowledge and how do you share it? How do you contribute together? I think that's very important. And then the other piece that we're forgetting often is that to be a SOC analyst and understanding all these different things is actually pretty hard. I don't know that many people that can explain well how a SWIG works internally in the WAF and an IDS and the firewall and the application layer firewall, and like it keeps going, right? Like how does this all work together? Get the business context as well, right? Understanding, again, go back to the context graph. You have to often have context. What does my business even do? What is important to them? What's the process that's running behind here? Oh, you know what? That's actually probably normal because they're using this weird system that's using us to communicate between these different entities of PLCs or whatever it is, right? It's a hard job. And again, I think now we're in an age where the system can help us bridge that knowledge gap.
Okay, interesting. I have a metaphor for this. SOC analysts are somehow like firefighters. Like they have fires. It's hard to do the job, and you have to do it fast, under pressure, etc., which leads to precisely the problem of dealing with alerts as singular entities that are isolated from one another. Again, coming back to something you said, and I think you literally called it the intelligence layer. So imagine you had this intelligence layer tool. Imagine you have it in place. What parts of the security operations models would change first? What would be the first impact on the SOC organization side that would change according to you?
I think first of all, we need this intelligence layer. We can't get around anymore, right? Like if we don't do that, a lot of the processes are very inefficient.
Cannot agree more.
So we need it, right? And I think we'll see more and more how we get away from a alert-centric view to a possibly, like if it's campaigns, or what I've been advocating for a long time is a risk-based SOC in a way, right? Where if I take all the alerts that are happening, all the telemetry I see, and I rate every single entity in the network in my organization with a risk, based on whatever is happening, I always know what the current risk is. I can start doing investigations based on the highest risk entities. So everything that goes over a certain threshold, I can start looking at, I get the full context, I can understand what's happening around that. So that's one thing that I still don't see that people are moving towards that, but I think it's the only right thing to do. Risk scoring is not easy. That's a whole topic on its own. That's one. The second piece is I hope that in 2 or 3 years, maybe that's a little aggressive, but that we don't even have the conversation anymore around investigation, because we gotta get to the world of automatic response and protection again. It's very interesting historically. We actually, in the early 2000s, it was all protection, right? You had the firewall that blocks stuff. You moved IDS to IPS to block stuff. Then we slowly, the pendulum shifted over to detection. And now we need to go back again, right? We need to what we learned from detection to bring it back into protection. And so I think those are some of the things that need to happen because the way we're doing it today is not working.
Yeah, I love it. And again, completely agree. That's what we're seeing. We're working hard to make it a reality, by the way, maybe sooner than 2 years, hopefully. But completely agree. I mean, we have a broken model as a whole. And as you said, we've been monkey patching it in a sense, rather than trying to redesign something, maybe from the ground up, start from first principles. And I cannot explain why, but clearly when you look at the SOC and the overall defensive security teams, from the outside, it just seems so inefficient. And you just sometimes wonder why many of the decisions have been made that led us to this reality today.
Well, I think I have an opinion on that, right? I think what happened is that we built systems that assumed homogeneity in the environments. So you're buying a Splunk or an Exabeam or whatever it is, and it comes with a certain set of rules. And we're assuming they all work the same in every environment. Now, what happened often is you scrub all that, you bring in expensive consultants that start building up these rule sets again for your environment, right? And that's just not how it's got to scale and work. We got to shift into something more intelligent. And nowadays, we finally have the technology to make it happen.
Absolutely. I agree with you. I think there's a tremendous technology shift that makes that dream a possible reality if we play the cards right. So again, thank you very much, Raffael. I really enjoyed the discussion. But now it's time for us to move to the probably funniest bit of the episode, which is the fire round. So the idea is absolutely simple. I will ask you a couple of questions, and the idea for you is to just answer them with whatever comes to mind first. Does that work for you?
Sure.
All right, let's give it a try then. So imagine a CISO tells you that their SOC is AI ready. What's the first question you would ask them to figure out whether that's true or not?
Probably around what percentage of their time is spent, or their analyst time is still spent collecting information rather than making decisions.
Okay.
So kind of like
Let's move on.
Context, right? Like, do you already have that readily available?
Okay, next question. 5 years from now, do you think that SOC analysts will continue to work in tier models? Because we still see that in a lot of places, if not almost everywhere, tier 1, tier 2, etc. Do you think that this model has a future, or do you think that we will completely move out of it?
I think no. I don't think we will have tiers, possibly 2, but the first is gone already. The first needs to be gone. The second and third probably is going to melt together as well. We got to reduce the SOC in terms of headcount anyway, so no.
Okay, interesting. All right. And maybe one last one. What is, from your perspective, the one skill that will in the future separate great security analysts from average ones in a world where you have AI native SOCs?
I think creativity, and with that comes sort of across domain thinking. Like, you have to have someone that understands, we kind of touched on that, right? Like the knowledge problem. Like, you have to have someone that can understand all the different components very quickly and come up with creative things, because the attackers are creative. The defenders need to be creative too.
Okay, love it. Awesome. So thank you very much, Raffael. That's it for today's episode. So thank you all that listened to the Super SOC podcast. And if you enjoyed the conversation and want to go deeper and see how we are trying to help build this intelligence layer and help reshape the way we do defensive security, please make sure to follow the show and head to Qevlar.com. And we'll obviously be happy to get back very soon with a new episode. So thanks for listening, and we'll see you soon. Thank you very much. And thanks again, Raffael. It was a pleasure having you.
Well, thanks for having me on. It was fun. Thank you.